All right. Thanks everyone for joining us here on the third or fourth day of the Summer Institute. This session is covering advanced Git and GitHub. So just a reminder, we're in the breakout room. So if you have any questions while we work through today's session, you'll post questions in the breakout room Slack here, where Cindy has also posted the link to the GitHub repo. So if you, like my previous sessions this week, we're going to try to work through some of the exercises covering Git and GitHub. This is my first time teaching this session myself. I usually teach the intro to Git, so fair warning, I'm not really that big of a Git expert. I just maybe know a little bit more than some. So Andrea Zanka, one of our colleagues, usually teaches this session each year. So I've always been teaching the intro one, so I've never actually gone through, had a chance to go through his advanced material. But I did that last night so I could prepare for today and sort of teach you what his material is. So I'll be basically keying off all of his material that he gave from last year's session. He was for some reason unable to attend this year, and so I'm covering for him. So we're going to just follow his material from last year. I don't think we're going to get to cover it all. It took me about 2 hours to go through steps 0 through 4 last night myself, so and we only have less than an hour and a half left here, but it'll get you started on the set of exercises, get things set up in your home directory on Expanse so you can work on finishing up later or coming back to it in the future, because he actually does have a set of recordings available online. So if you go to the GitHub repository for the Summer Institute, for the advanced Git and GitHub session. So you'll see the 3 main links to the material from the previous year. So we have the, he has a few slides there that I think are too helpful necessarily. There might be a little bit of extra information from last year there if you need to check. The main repository we'll be working with is this conversion to fix on his main GitHub page. So this is still the main set of material that you'll follow when you want to go through all of the steps. I've gone ahead and made my own notes on steps 0 through 4. So we'll try to get through those during today's session. And then you can finish up the rest that go through, I think, 10 for all of the videos and things, which are also available on YouTube, right? So even though there's only 4 videos and each one is less than 10 minutes, it literally took me, I think, yeah, 2 hours to get through and process everything in my brain, going from 0 through 4. So, so the videos go fast. So if you're going to work through these later, you'll probably stop and start them and, have a think and maybe you'll mess a few things up and have to fix things. But he gives pretty good instructions throughout the videos that I've covered and in the notes here to sort of do it yourself. So I think actually he usually just presents the videos and then answers questions for the attendees. But I kind of thought it'd still be good to just go through everything with you step by step and show you sort of how I process the material, learning it myself, because most of the tools that he talks about in the material I haven't really used myself. Most of my Git experience is just managing my own repositories, not really developing in a large group of people where things get a bit more complicated, where you really have to have a set plan of how you're going to develop a repository and create branches and bug fixes and sort of how to collaborate between team members. So we're working on a project right now in our group to hopefully do that with our new software stack. So I have a little bit more experience, but I'm still sort of learning myself. So yeah, so let's go ahead and get started. So we have a little bit, an hour and 15 minutes to go. So So the first step, if there's no questions before we begin, those are all the disclaimers and sort of background for what this talk is about. So if you are a Git expert, yeah, maybe you'll learn something new. There's some tools that I've never used before, but I'll make comments too about what Andrea talks about at some points. Like for example, we'll go through the Git bisect tool, and I don't think he actually covers it in the video, but I made notes because I really hadn't used it myself, so I wanted to see how it works. So there's more extensive notes, for example, on that in the repo for this year's session. So, okay. So what you need to do is log into Expanse. So open up a new terminal for today's session to your training account on Expanse. I've cleaned up my home directory. You might have more files in from the other sessions. So, hopefully there's not too much clutter. If you want to work out of say a different directory, I'm just going to work out of my home directory, but that might help you sort of stay focused on the files in front of you. But today we're working out of mostly this conversion to fixed repo. So that should, hopefully help eliminate too much file clutter as you work through today's exercises. So the first step that Andrea walks through in the videos is sort of preparing the setup in your home directory to follow all of the exercises that he has in steps 1 through 10. So that's what we're going to do here. He talks a little bit about modules to begin with, right? If you log into Expanse and you type module list, you'll see that there's a set of default modules that are loaded. This isn't too important, I think, for today's sessions, but sometimes when you're working on HPC systems, people tend to sometimes do module loads in their, if they're using the same set of software regularly, they'll sometimes module load things by default. And so you might have a slightly different default. So he just wants to make sure that if, for some other session during the Summer Institute, or maybe you've done yourself, loaded some sort of default modules just to sort of reset the module software in your environment to the default. And the way you can do that on Expanse is we have this module reset command. So it'll, if for whatever reason you have some extraneous modules loaded, the module reset command will get you back to the defaults. So that's just a useful command in general. But since we're using GitHub today, and we'll be using in particular the GitHub CLI. Okay, so if you haven't used the GitHub CLI, this is a command line tool that GitHub has developed to make your sort of GitHub specific workflows simpler to use. And so if you haven't used this tool before, you'll get to use it today. That's sort of one of the main aspects of the exercises that we work through. So if you want to, you can check out the website later to see everything you can do. It's kind of a nice looking web page. Shows you a bunch of different examples of how you can work with, standard GitHub sort of checking on pull requests, checking things out, completely interacting with your GitHub account and repositories from any command line that you want, essentially. Okay, so that's one reason that he's asking us to just reset the default environment so we kind of know that everybody's on the same page with what software they're going to be using. We do have, as you know, it's a GitHub CLI module that's available on Expanse. And you'll see it here. You can do a module load GH. You can just double check the version with the -- version flag. And you'll see here, this is kind of an old release. So I tested it last night and it works. In general, so we'll use this for today. In general, I probably would not recommend using an old version if you don't have to, right? As you'll see when we start walking through this, we're starting talking about security and authentication, SSH keys to access your repos and your GitHub accounts. So using an old version like this long term is probably not what I would recommend. So this is something we have to discuss on our own team's end of like how often that we keep this thing updated. Obviously, this is a pretty old version. I don't think anyone's probably reviewed what the bug fixes have been since, or what security issues there might be. So there is, though, if you go to the GitHub CLI, maybe I can try to do this. There's downloads, view installation instructions. Yes. There are downloadable binaries that you can get from the release page. So for example, if you click to the latest release tag of the GH package, you should see an ANB64 tarball here. And if I copy that link, download it. Oops. Sorry, my copy and paste is kind of weird sometimes here with this new computer. So I need to get it fixed and try that again. Copy that link, wget. Okay, so if I extract this tarball, there's probably a binary that will work on Expanse as well. So long term, when you're working on an HPC system, downloading the latest version of the GitHub command line tool, if you really like using it, if this is your first time getting a hold of it and familiar with it, and you like using it long term, I would usually recommend downloading the latest version. They have precompiled binaries, and they should probably work on most systems that you're going to use it on. That's kind of the best way to keep not only the HPC system you're working on safe, but most importantly, your GitHub account, your repositories that you probably don't want other people to have access to or be able to delete, or whatever bad things that might happen from using an insecure repository. So let's see, maybe. So for today, if you want to use that binary, you can. I haven't tested it, so I'm gonna fly a bit closer to the sun and just follow the instructions as I tested last night. So, but you can revoke the credentials and things to your GitHub account once you're done for today. That's what I would recommend, just to be safe. Okay, so so that's one comment about a thing I would change about the tutorial as written right now. But let's go ahead and press on. So when you do start working with this GitHub command line tool, you first need to sort of prove to your GitHub account that you are who you are. And so the first command that you do to set up that trust relationship is with the GitHub auth login. Okay, so you go gh auth login, and then the command line tool will give you some prompts of, like, in this case, it's asking you what account do you want to use, or what account are you trying to log into. So if you're using some sort of enterprise account, you might have, you would select enterprise accounts. For this session, we're assuming you have a github.com account, so that's the one that I'm going to choose. And the recommendation, since we don't want to use well, to when Andrea talks about this, he says, to sort of simplify the interactions, we're just going to use SSH keys to make all of the secure transactions essentially between Expanse and your GitHub accounts online today. So you'll click on SSH instead of HTTPS, unless you already have. If you want to go the other route, feel free. But the instructions are to use SSH keys. If you've been using GitHub a lot, obviously you know that there's no more passwords, so you would have to. If you used HTTPS, you'd have to set up a personal access token and all that stuff. And we're just going to do SSH keys instead today. So maybe in the future we'll do the other option. Okay, and so if you select SSH, the next step is it'll ask you if you want to generate, or if you want to generate a new SSH key to add to your GitHub account. Now, we walked through generating SSH keys during one of my other sessions on data management to help sort of facilitate logins easier to Expanse this week, sort of get you away from entering the password all the time. So what we're going to do, but those keys, remember, were between your local system and Expanse. This is now a new key that we're going to generate on Expanse that will live in your .ssh directory on Expanse, and create that trusted pair relationship between your account on Expanse and your GitHub account on the somewhere in the cloud, somewhere on the Microsoft cloud. What you're going to want to say is yes to generating the new SSH key. And as I discussed when generating SSH keys, what is one of the pro tips that you always want to do? You do want to use a passphrase. Otherwise, for example, all of the staff have access to your passwords for your training accounts this week. So in theory, if you don't use a passphrase here, we will then have access to your GitHub account for however long you leave these keys in the training accounts. So don't leave the passphrase blank. Enter a passphrase. You can use the same one you used generating keys earlier. It's just a better way to keep your keys safe, your account safe, and again, it's being a good steward on a shared system, right? Because if there's some security breach, someone gets access to your keys with no passphrase and then has access to your GitHub account and they delete your things, you might get upset. And, we'll be upset as well, but this is why you want to use a passphrase. And so this is one thing that you do not want to follow in. I think Andrea in the video doesn't use a passphrase, so we'll have to ask him to change that in the future. Okay, so the next step is it'll ask you to, basically what it's asking you is, right, just like when we generate SSH keys to log into Expanse, it's now asking you to sort of, I want to copy these keys to your GitHub account. But they're like, okay, that's fine, but you have to, again, authenticate some other way, because how do we know to trust these SSH keys? Well, you'll do the login with browser option. Okay, and so it'll give you this one-time code. And, that's actually, I don't think you want to copy it, but what you want to do is go to this link here to log in from device and enter that activation code that you were given from the GitHub command line tool. So I've got 7592. If you have not logged into your GitHub today, I'm already logged in. You might have to log in first and then enter the one time. But go ahead and follow their instructions as it happens. I think you'll probably have to log into your GitHub account first, then enter the one-time code. And then, right, this is sort of the page you'll eventually get to once you enter the code, right? So it'll, you're authorizing this, GitHub command line tool that is trying to upload, some set of keys. and allows you to do all of these things. So we're just going to click the defaults authorize, and that's all you would have to do. Okay. So I'll give everyone a second to do that. At the end of today's session, if you want to sort of, be security conscious and remove the keys from your GitHub account, it's under your main settings. And in the SSH and GPG keys section. So should see here. Oh, I haven't finished the process. Okay, so yeah, once you finish entering the one-time password, you just click enter, and then you should eventually see an authentication complete. Press enter, and if everything looks good, you'll see uploaded SSH keys to the account. So this is kind of just doing an SSH copy, and now I see the new key that I've generated here. So the public key has been copied to, and authorized for reads and writes to my GitHub account. Okay. Okay, so that is setting up the GitHub command line tool. All right, so all of those notes and sort of outputs that you should see are again in the repo here. So if you're not following along now, hopefully it'll be helpful as you work through it later or follow the videos from Andrea. Okay, let me just check if there's any questions so far. No, okay. So the next step is to, well, we're still in step 0, is to clone the repository the examples are based on. So this is your next GitHub command line tool. To clone a repo, you just do gh repo clone and point to the repo. So I don't really know how it's any different than a git clone, but I guess it allows you to make a little bit shorter URI, kind of just pointing to the GitHub user account and the name of the repo. Under the hood, it's probably not too different if I had to guess. But so the one difference you'll see from the videos on YouTube is, right, if you generate a passphrase, you'll be challenged for that passphrase. So I'm going to enter my passphrase, and then the repo will get downloaded. Right? So once you have that repo downloaded, you can just change into that directory, because all of the exercises for the rest of today will be out of that repository. Okay. So we've cloned the repo, and you can kind of just poke around inside. There's a few different files: a README, a license, a conversion.py, and a test conversion.py. So the file that we'll use today is really the I believe the test conversion.py. So we'll get to that in a minute here. But anytime you start up on a new system and you haven't used Git there before, right? You're probably familiar with, you have to sort of do your basic Git configs, right? And so just like you would on any other system, you'll want to configure your username, right? And it would help, I think, if you use all of your standard configurations that you would use with your GitHub account. So I'm going to use my SDSC email here for my user email config. Then you want to choose what editor that you might use for, even though I think in most of the exercises we don't really use the editor too much. We just kind of take the defaults that get populated. Choose whatever editor that you're comfortable with. Use Vim. And then you can just check what the config list looks like. Just make sure that you have everything good to go. So you'll see there's a few other things that have already been set up. For example, so if you want to see something that the GitHub repo clone command does, probably a little differently. Maybe it's already set up some origins and a few other things. I don't know, have to do a side-by-side test with just to get clone. Anyway, so yeah, so once you have your basic git config ready, that's the end of step 0. Okay, so we're basically ready to start all of the exercises that work with this repository to just teach you some new tricks and things about working with Git in sort of a GitHub in sort of this more advanced way. Question. Oh, that's right, in the main room. Okay, so the first step in the exercises, once you've set everything up, is to run a test. So the idea here is you have some code you're working on, and maybe you've made a change recently or sometime in the past, and you're just running some sort of set of tests, and you come across an error, and basically there's a bug in the code somewhere is what you'll find, right? So this is the sort of a contrived example, but it's I think it's somewhat illustrative for what you might be doing, but kind of assumes you're doing lots of testing with your code in sort of I think an automated fashion, but it's a simple example to sort of illustrate some points. So if you run this test code, you'll see there's this assertion error. So it's not really too important, if you're not familiar with Python programming. It's just know that there's an error in the code. It's indicated by running this test, right? And so the idea is, for this first set of exercises, is how do we go about finding where in our Git history this error was introduced and fixing it, right? And then letting Andrea know, the original developer of the code, that you found that error, and that you generate a pull request with the GitHub command line tool. And that's kind of the goal for the rest of today's session. So that's all the way through step 4. Okay. So, all right. So the first thing that's suggested is, as a quick check / debugging method, is, okay, well, let's say you were working on this and you pretty regularly running this test. It's like, well, maybe it was just the last commit that I made the mistake, and I want to just roll back one commit, rerun the test, and see if that's where the bug was, right? So the first command for this quick check is just to check out the last commit using head tilde 1, right? So this is the first thing to do, is just roll back one commit, right? So you've kind of in this detached head state now. And you'll notice that I didn't look at the log beforehand, but this is the second to last commit at the top of the history for the repo. You can probably go to the main repo here. Okay, so the last commit was explain clone, so I rolled back one to this module load gh. You can see if I run git log. Right. So we're now at the second to last commits in the repository. So the idea here is, if it was really the last commit that the bug was introduced, you should just be able to rerun the test. But we see that the error is still there. Okay, so that's not where the bug was. So one of the sets of instructions that Andrea gives is like, okay, well, if you start poking around in the history like this with rolling back different commits. At some point, sometimes you just get like a little turned around and confused. And so you just want to go, let's like stop and go back, reset everything to the original state of the repository when we found the bug. And that's what this last step is. So what we're going to do is, all right, it wasn't in the last commit. So let's just go back to the original state with git checkout main. And that'll roll back to, if you run a git log, you'll see that now we're back at the top of the repository, the explain clone in the history. And so that's the end of step one. Okay. So if it wasn't in the last commit, what can we do next? So, there's not, so what we're going to do in the next step is review the git bisect tool. So I've actually never really used it much in practice myself, and I think Andrea admits that most people don't use it in practice themselves either. When they're sort of searching for a bug, I think most people kind of just wing it and sort of review the history and changes in code, and it's like, oh, that's probably where it is. But for simple bugs like this one, I think it's it's a pretty powerful tool, I would say. I think long term, it might be a pretty powerful tool if you're working alone, right? Because in general, if you're working alone, you're probably not doing a whole bunch of branching and independent developments along those branches. So, I mean, most of my repositories are all just along sort of the main branch. I just kind of routinely update it and use it more as just a way to document my code as it's being developed. And so, if you really just have like a single branch, maybe two, this is probably a pretty useful tool, I would say, to really dig down to where the bug is. But of course, this assumes you have tests in place that you can run really easily and check. And if you're, for example, writing a simulation code and the bug is, not obvious, per se, it's, and it takes a while to run those tests that, where you found the bug, it might not be that useful. But for simple bugs, I think, if you really get stuck and can't figure out where something is, this is one thing to be aware of if you haven't used it before. And I don't know, maybe once I get more experience using it myself, I'll have more of an opinion, but we'll see. So, Andrea actually in the video from last year doesn't actually walk through these next steps. So these will be additional steps that you won't find in the video. So definitely refer back to these notes if you walk through this later. And so what the problem is with git bisect is you sort of have to have an idea of where the bug was introduced, right? So you have to, we know that the bug exists in the current state of the repository, right? That we cloned from his GitHub account. But we don't know exactly where it was introduced, right? And so the question becomes, because we need to know some point in the past where the bug was not there, or that we assumed that it was not there. And so how would you do this? Especially in this case, we're working with someone's code that we don't know what they were doing, when and where, and when they were working on a particular function. This is a pretty simple repository, so we can dig through each individual function, and we know exactly what function the problem's in with this error. So it's a little bit easier, right? Because we know that it's, rerun the test, it's related to this gallons to liters conversion issue, right? So we know there's this function somewhere that's gallons to liters, and there's a problem, and we have to figure it out. So I think what you would naturally do is review your Git log or your commit history on your GitHub page. And that's kind of what I did. to, because I honestly didn't know myself when I was walking through this where the bug might be. Of course, Andrea gives you a little hint in the video, and he actually just gives you what commit the bug is in, so you can skip these next steps. But we're going to walk through it, assuming we don't exactly know. So what I did is I looked through the is that for me? Main room. Okay. Sorry, I guess maybe a note for Cindy. That's one problem with the Slack chat. We still see pop-ups from the main room when we're in the breakouts. So, okay. So yeah, so what I did is I just kind of looked through the commit history here online, and it's like, okay, do I see anything that has to do with gallons to liters to pick out where like maybe the problems were starting. Okay, so here's a reference to gallons to liters, right? I think this is the one that I actually chose. Right, so I'm like, okay, well, this gallons to liters commit looks like it's this, yeah, this is this function, this gallons to liters function that's having the problem. And if I go to Google, gallons to liters, that looks like whatever he wrote there is using the right conversion factor. So it seems like this commit was correct at this time. So let's use this commit as the one we're assuming that everything was working at this point in the code, right? So that's kind of what I did to sort of take a stab at using the git bisect tool. Okay. So what we have to do, if you haven't used git bisect before, is you start it. So you actually, it's kind of a series of steps that you do. So you do a git bisect start. Okay. And now you have to start labeling the commits. So we know that the current state of the repository, that this commit, we know the bug that we're looking for is there, it's been introduced. So this is a bad commit, right? So for git bisect, you always need a bad commit and a good commit to start, right? And so our good commit will be the one we just found in the history that we're assuming is the good commit. So you can copy this and label that one as the good commits. And what you'll see is this output, that there are, if you look at the history, this, where we've chosen the good commit, there's been a few commits since, right? So this is, from August 2017. So Andre has been, giving this talk for a while, and this example has existed for a while. So this is where he originally introduced the bug, right, or created this this test repo. So, but so there's 8 different possible revisions that we sort of have to step through and test whether or not the bug is still there, right? So let's see, if you scroll down a bit in the repo. So what you want to do is what the git bisect tool has done, it's changed what commit you're now on, right? So it's just running a simple bisect algorithm to sort of narrow down where the bad commit might be, right? And so it's very simple in this case. All you have to do each time you rerun the bisect tool is run the test conversion.py again. So all we have to do is run Python 3 test conversion.py and see if the bug is still there. All right, so in this first new commit that we're checking, the bug is still there. So what do? With the git bisect tool, you just do a git bisect and label it, well, this is still a bad commit, right? And then we rerun the tool. the error is still there. So again, another git bisect bad. Rerun the test, still bad. And then run the test. Oh, there was no error, right? So this previous, between the last two commits is where the bug was introduced, right? And just something that I threw in my notes is, if you're not familiar with like running sort of standard Linux tests, right? Anytime you run a Linux command, there's this special character you can use to test the error code, right? So if you run a command and it's successful, usually it should spit out a 0 error code. So if you just echo $? Like this, did it run correctly? $? I guess that's what it means. I forget exactly what the name of the character is, but it's one of these special character sets that outputs the exit code for you. So this did run correctly. Everything was fine. There wasn't an issue, right? So we know now that this is a good. Git. Sorry, there was a question. I'll get to that in a second. You'll label this as git bisect good, right? And so there it points out what the bad commit is. So it's basically, if you follow Andre on the video, he shows you that there's actually these, he took off a few digits to the liters to gallon conversion factor. Let me just stop here. And so that's what this commit is for removing extra digits. Let me go. There's a question. Does the git bisect tool automatically roll back the commits? So we're going to get to that, David. That's a good question. So what we've done here is we've labeled, basically after you label all the bad commits, right, you then find the commit that's good. So we just labeled that good. So now Git is able to identify the bad commit, like the one that we were looking for. And so now what you want to do is do this git bisect reset command, right? So it doesn't automatically fix the problem for you, right? All it does is help you find, it's really just a tool for automating this, bisecting algorithm for your review of the code, right? So since we knew that just running this simple test, we could find, once the test was good, we were able to quickly find this commit that where the problem was introduced, right? So yeah, if you have much more complicated tests when things start failing, I think it's personally going to be hard to use the bisecting tool. But for very simple things, like if you have like if you had like a typo you introduced somewhere and something just keeps failing, you can't figure out where it is, I feel like that's like really good for the bisecting tool. Like, I mean, this is literally a toy problem about some typos on a conversion factor. So you might have that. You might accidentally have that problem. I've been developing code, and accidentally, run a character delete, and I didn't want to run a character delete, and I can't figure out where it's necessarily getting introduced sometimes. Something like that might just throw things off slightly. And so that's kind of where I think this kind of has a niche, just small fixes that aren't sort of more systemic type bugs. It's kind of what I think I would start using the bisecting tool for, just to find little things that seem off that if there's like a feature in your code that you're developing that you don't use very often, and you accidentally deleted something at some point in the past, and figuring out where that is might be kind of where this is useful. So we ran this git bisect command. So this basically does the reset to the original state of the repository, right? So the question is now, how do we go about fixing it, right? So the git bisect tool doesn't fix it for us, but it allows us to find where the bug is, right? So the next thing that Andrea says is basically, okay, so we found the commit. You can then look at what that commit was with the git show command. So if I run the git show command with the git commit hash that we found, you can use a shorter version of the string as well. It should work. You see that this is the bug, right? Where he accidentally deleted the 4 and the 1 here at the end of this conversion factor. And that's why the assertion is failing, right? So the assert is basically saying it should be this answer, but when we run that test, that answer is wrong because, well, that we've messed up the conversion factor here in the function for the code itself. Okay. So that's how you can just review the commit. Now the question is, okay, so how do we fix it? So what we'll use here is this revert command. So basically, this is the command you're looking for, David. So what we first do here, just to keep things, when you start working with more complex codes and start developing with other people on the same code, you really want to get familiar with working with branches. I know I think the description of today's talk was, you should already understand pull requests, merges, branching, rebasing, and all that stuff. But so far, at least all of the material I've gone through doesn't really assume that. So, because it's kind of the first couple of things we do. So if you're not familiar with working with branches, this is, working with coming up with some system to manage your branching, and when you create branches is kind of a philosophical development topic. I think one of the most popular ones, if you look up, is sort of the git flow method. Let's see, there's a nice reference out there somewhere. Yeah, Atlassian kind of has a nice set of documentation on git flow, and sort of, it's when you start working with multiple branches, multiple developers working on the same code, things get really complicated if you don't have a plan. So there's plenty of different ways that people manage their repositories and updates. And if you're working on a bigger team, you might already have something like that. But if you do plan on doing that, you should sort of have a plan in place if you're not working solo. So that's my recommendation. So this is kind of what I've personally been working off of, trying to understand sort of more advanced features of Git when you're working in this kind of situation, and sort of the different issues you need to think about and how you're going to maintain code over time with multiple people making commits to a single repository. So this is, if you're not familiar with this is maybe a good place to start thinking about these types of workflows. And one of those recommendations is there's different types of branches, and usually this is what we're doing here would probably be called like a hot fix bug. And so basically you just create a simple branch right off the main development branch for the repository. Do the quick fix, because obviously in this case it's very small, very tiny, and it's should be easily to insert, and everybody's going to agree right away that this should go in, right? So that's kind of what this hot fix bug kind of branch would really be for. That that you just want to make a quick fix. It's not really going to have a huge impact on, say, everybody else on the project, and this is what you would do. So just if you're going to branch out, you do a checkout, git checkout -b and name the branch. That's what we're going to do here. So now we have two branches in the repository. You should have a main and the fix bug branch. And this quick fix, since it's a single commit and we know exactly what, it's a single function, you can use this git revert command. So this is really that sort of automated fix where basically you want to undo the commit that we know caused the problem, right? And so that's this git revert here. So you just do git revert and the commit ID. And so that's all we're going to do here for this quick fix. And if you want to add extra dialogue to commit, you can. I just left mine as the default here. So I'm going to commit that. If you look at the log, you can see that, you know, there's the main branch here. We have our fixed bug branch is ahead of the main branch by this one commit now. And then we'll rerun the tests, right? So by running that git revert command, we should have undid that commit that we saw where the 2 extra digits were left off of the conversion factors. So if we rerun the Python test conversion, it should be good. And you can even see like things have changed a little bit more than previously, right? So when we were doing the bisect command, we didn't get this testing completed message, right? So there's even still something else that was a slightly different from that original commit that was introduced since, right? So we still have all the changes that we wanted from all the good commits along the way in the development branch, but we just fixed that one issue in place in that one commit by running the git revert, right? So everything passed the testing again. There's a positive exit code. So the bug is fixed, right? So what do we want to do now? So I forget exactly what he does after this next step, but this is step 4. Let me just check how we're doing on time. I forget when this session ends. We started at 8. We're supposed to go till 9:30, I think, right? So we'll have maybe a little bit extra time for you to start working on steps 5 through 10. But the last step that I'll cover today, you know, before we go off and start working on our own, maybe on step 5, is to not necessarily merge the changes here yet into your local development branch, but what Andrea has is you create a pull request to him, basically. So you want to say, hey, I found this bug in your code. I created this, you know, this hot fix branch for you. And this is, you know, this is kind of the way you want to do it when you start working with multiple people developing on the same thing, right? If you are going to make a change to the code, you want to create like a separate branch before you create a pull request, right? It's just much easier to manage things long term, because right, if the change is something more complicated that people don't want to add into the code, you know, they might not take that branch and try to merge it into the main development branch of the code, right? So it's just a good practice. So the step 4 here is to you know, submit that pull request to Andrea using the GitHub command line tool. So you can use the GitHub command line tool to do all the sort of extra things that GitHub does for you that you sort of, sort of helps make simpler than doing it all manually yourself in Git directly, right? So this is kind of a nice, or, you know, doing it all through the web that you would have to do as well. Like, for example, you know, if we wanted to do this sort of the more traditional way, there's a lot more steps involved, right? So, you know, you would basically have to create a fork of Andrea's repository to your GitHub account, you know, submit your changes to your version of the fork, then create the pull request from your fork over to Andrea's. And so this GitHub CLI, just GHPR create command, is actually going to help automate that all for us right now, right? So if you've ever done that process, I found this quite nice and simple. And so this is one I think for me was, this is a nice example selling point of why you might want to use the GitHub command line tool long term, especially if you're doing these pull requests a lot. I don't necessarily yet, so but if you are, I think you'll find it quite nice. So GHPR create. So that's the next step. So let's go ahead and create the pull requests. Again, like the authorization process, is going to walk you through a series of questions, right? So where, this is obviously, where do you want to push the bug branch? So obviously, if you were to do this all manually, you would create a fork first of the repository in yours. So that's the one you will choose here. And now it's going to, now that we've basically forked the repository, which we can check if it's available in my repositories now. Maybe not until after I complete these commands. Probably not. So then it's going to ask you, okay, well, once I fork the repository, what do you want to call the, you can name the title of the pull request. I'm just going to leave everything as defaults. You can enter more information into the pull request. For example, right, if you're, let me see if I can find, right, it's basically, let's see, it's basically, this is an issues section, but if you look at like pull requests and issues, they kind of look the same, where you have some title, then you can add, it's asking for the body text, you can add extra things you want to talk about. Actually, this is a suggestion from Andrea here, actually, so on this other code, but just to keep things simple, I'm just going to skip writing anything into the body. But, if you were to see the pull request later, the body text would obviously be kind of in the comment section here. And then you'll just submit the pull request. Now, obviously, now the GitHub command line tool is doing all the authentication again. It's asking me for my passphrase. So it looks like at least the GitHub command line tool doesn't load your keys into the agent. So it keeps asking for a passphrase every time it wants to use it, which is probably a good thing. Oops. Typo. Okay, and so once you enter your correct passphrase, you will see this text that you basically now see that I have created a pull request from what is now a fork of the conversion to fix repo in my account. So now we should see it in my account. Right, so you see I have a forked version from Zonka conversion to fix, and branches up to date with Zonka conversion to fix. This is obviously on the main branch. There should be a fix bug branch that I made the revert to. If you go over to Andrea's version and check out the pull requests, we should see a few of us have actually been following along and completed the task. So that's cool. All right. So that is, I think, basically it I had from reviewing at least part of the series of exercises from Andrea's training material. So let's go back here. So if you go again to the main repo, again, there's a bunch of other steps. I haven't had time to walk through them myself, but hopefully at least getting you started here with those first set of exercises, will encourage you to continue on. So it looks like there's a few other more complex tasks about sort of synchronizing with the upstream repository and rebasing probably your local one. Let's see, synchronize upstream with conflicts, race a commit, hard resets. The ones that, yeah, so I would definitely, if you've liked the material so far and you think it's been helpful, I mean, I think, the videos are quite nice, and you should be able to follow along and complete these tasks. The ones that sound most interesting at the end is, I think he does some GitHub actions. So I haven't used GitHub actions myself. This is one way to sort of automate different processes with your code on GitHub. And so, for example, I think if I had to imagine what this task is to sort of create a GitHub action that probably runs that test code over and over again. And every time you make a change to your version of the code, right? So all of these things that we've been doing manually running, the Python test conversion. I think what he's going to get to by the end of the talk is, how to set up GitHub to do that Python 3 test conversion test for you automatically every time you make a change to the code. So you always know that that test is either passing or failing, right? And that's kind of useful. So if you do start creating a series of tests for the code that you're developing, this is one way to help automate that testing process. So it's not, you're not doing it manually every time. Now, whether or not that's feasible, for the type of code you're developing and the resources that are involved, I mean, I can just, comment on that sort of, because I think this pull request actually from Andrea for this other code that I'm working on. That he suggested is, it's over here. Yeah. So this is about building containers using GitHub Actions. He sort of developed a demo to show how you could do this with some code that used to exist for Singularity. That I'll talk about Singularity again tomorrow. But he recommended, trying to set up some demo of using GitHub Actions to run the this code that someone else developed previously to sort of help automate the building process of these containers through GitHub, right? So essentially behind the scenes, GitHub running these GitHub actions, they basically allow you to spin up tiny VMs for a little bit to run these tests, essentially, right? So if you set things up, these GitHub actions are running on sort of Microsoft's cloud somewhere on some, fairly limited VMs is what I would say. So I think a couple cores, a couple gigs of memory, and I forget if there was a time that you can look up how long they'll run. Yeah, so there's kind of a maximum execution time. So if you are developing tests and you want to do it through GitHub, just one thing you have to keep in mind is that there's a limit to the resources that are provided for free, right? So that you would get a few cores, a few gigs of mem, a little bit of disk space. But for example, one of my problems for this project at least was we do have some of the most popular containers that we build and would build and then automate the testing. They take much more resources than are available for free from GitHub. So they might have a paid service, but I don't know, I haven't investigated too much. But that's one thing to keep in mind when, if you go down the rabbit hole of really using GitHub Actions a lot, depending on the types of things you're automating, and there are resource constraints. So just keep that in mind.